Good day, my Algebra 2 peeps. This is to help you as you're working on this packet, and it's particularly for when you have to graph the logarithmic function. And notice, I'm going to show you real quick the 6 examples I'm going to do. Here we're going to do the common log with a base 3. And let me just say this is going to work no matter what your base. But here I'm subtracting 2 inside the parentheses. Here I'm going to subtract 2 on the outside of the parentheses. And then I'm going to show you a few towards the end of the natural log. And again, here will be the basic one. And this was got, again, we're messing with your x, so it's inside the parentheses. Here it's an afterthought, doesn't mess with the x. So that way, if you want to scroll towards the end of the video or whatever, you can. I'm hoping, okay, that you'll recognize the graph of a basic logarithmic function no matter what the base is. Because what I did here is I went ahead and picked out some values. You can plug in anything you want for x as long as it's greater than 0. Remember, you can't plug in negatives, and you cannot plug in 0. Try it on your calculator, and it will give you a syntax domain error or something like that. And the reason being is, remember, what we're saying is here, this is your base. 3 to the what equals x. And there's nothing, 3 to the nothing, let me write that, would ever give you 0. So that's why you can't take the log of 0. So later when it talks about your domain, I'll show you that here in a minute. Your domain is always like 0 to infinity for your basic function. Okay, so you can pick anything what you did. I did powers of 3. So first of all, I want to know 3 to the what, right here, equals 1. That's what this is asking, which is going to be 0. Now you could hit this in your calculator, but it is good to know it for yourself. So if you were going to hit this in your calculator, log base 3 of 1, the way you hit that in your calculator is you do the big number, this guy first in your calculator. So you're going to hit the log of 1 all over the log of 3. Hit it in as a fraction, okay, and that should give you the answer 0. So test it on that one, because there are later, when you get down in here, you're going to have to use your calculator. Okay, when you put in 3, log base 3 of 3 is going to be 1. Why? Because 3 to the first gives you 3. Log base 3 of 9 is 2, because 3 squared is 9. This would be -1, and this is going to be -2. Okay, so just plug those in your calculator. Think about it a little bit. We talked about those in class. Let me just do this one real quick to make sure you can see it if you didn't have a calculator, and I want you to see how it works, but that's what that is. Remember, this is the same thing if I flip this as 9, oops, I forgot to write my little base 3, 9 to the -1. I could write this as the base, since this is base 3, I want to have this base 3. Okay, I could also bring this exponent out front if I wanted to. So I could have this -1 times log base 3 of 9. Well, we all know that 3 squared is 9. So this right here is 2. And -1 times 2 gives me that -2. So that's one way to do it. I could have also written this 3, right, excuse me, this 9. My mouth is not speaking with my brain. 3 squared is 9. Notice I still have a -1 up there. So again, this equals 1. When these are the same, you can always bring this out front. So I have a -2 times 1. So just kind of mess with this. If you can't see it, use your calculator, okay? Because you need to be able to plot points. I went over here to save time, and I went ahead and plotted them. But remember, every logarithmic function, I don't care if this is base 2 or 5, I don't care what it is, 4, it's going to look like this. The only difference is sometimes it's going to come up a little steeper, or maybe it's going to be a little less, but it's going up slowly. And I tell people you can remember the logarithmic function. And notice he's down here hugging the y-axis, okay? He will never touch the y-axis, because remember, this can never be 0, but it can get closer and closer to 0. So by definition, this is your asymptote. So all vertical lines are x equals something. So this would be x equals 0. You can see my domain is 0 to infinity. Okay, remember your domain is how far it goes from the left to the right, so it's not going to quite ever reach 0, and then it goes off here to the right. My range is how far up and down it goes, so it's -infinity to +infinity, and it has to be written in this order for it to be correct. Okay, so that's the basic function of what they all look like. Now, what happens if I subtract 2? Well, the first thing I would ask you is notice that x can't be 2, because if it is, this would be 0, and you can't take the log of 0. So I got to make sure that I only plug in values greater than 2. In fact, my domain, because I ask you on those, would be 2 to infinity. That would be your domain. Your range is always all real numbers. It's kind of the opposite, because that's what these are, of the exponential function. Okay, so if I was going to graph this, I can't plug in 2. Okay, so I'm not going to even worry about it. So I would plug in 3. That'd definitely be something I want to plug in. And 3 minus 2 gives me 1. So this is going to give me 0. And again, use your calculator for this. If you are having a hard time thinking about this, this is what you get if you plug in 3. 3 minus 2 is 1. So to hit that in your calculator, you're going to hit the log of 1 divided by the log of 3. Okay, but hopefully you're going to get to where whenever you take the log of 1, it's always 0. Okay. What else might I plug in? Okay, I would plug in 5, and I want you to think for a second, why would she plug in 5? So, before I say why, I want you to think about it. Notice if I plug in 5, I get 5 minus 2, which gives me 3. Well, look, when those are the same, I know that equals 1. So I like to do powers of 3. Not multiples, but powers. So I would love the next one to be a 9 in here. So I would probably plug in 11 because 11 minus 2 is 9. So I know this would be 2. And by the way, if you're going to hit this one in your calculator, it's always log base 3. If you plug in 11, 11 minus 2 is 9. This is what you want to hit in your calculator. And in fact, you can just hit it in like this, log base 3 of 11 minus 2. You can hit it in like that. The way you would do that is you're going to take the log of this big part right here, make sure you put that in parentheses, all over the log of 3. So you can hit it in like that, and that'll give you 2, or you can hit it in as the log of 9, because you put him on top, all over the log of 3. Okay, so that's going to give you these values. All right, so look at what we got. I'm going to go ahead and graph this. I've got 3, 0, and I think I'm actually going to plug it in right here so you guys can see. Do I want to do that? No, I'm going to plug it in here. Change my mind. Here's 3, 0. And what's my other one? 5, 1, and 11, which is right here, about 2. So you can see it's going to be like right here, okay, just like this one. But I couldn't have a 2, so that's my asymptote. I'm going to go ahead and graph this in there, okay. And this is what I know. I know it's going to go down here and it's going to hug that asymptote but never touch it. So technically I could plug in values right here. I would want this value honestly to be 1/3 if I was going to plug in a value. So I would probably take 1/3 plus 2, which is what, 6 7/3? Is that right? Okay. So I would let x be 7/3. Okay, and I would plug that in because 7/3 minus 2 is 1/3, and then you could use that in your calculator. Okay, so again, you can just plug them in there, but that's going to give you actually a very nice value. It's going to give you what, -1? Just a minute, I'm thinking, because what did I get if I plug that in there? If I plug this in there, I get 1/3. Well, yeah, -1. I'm over here thinking about something else. Use your calculator, plug that in, okay? I would also love this to be 1/9. So if I had to show my work, I might plug in whatever 1/9 is plus 2. Okay, so let's look at this. What, when I, subtracted 2, what happened? And this is true in all, when we did parabolas and ellipses and everything, when it messes with your x, it messes with your mind. We all know x goes back and forth. So you would think this is going to go left too, but I want you to look what it did. Here's my standard one right here. Went through 1, 0. This one's going through 3, 0. So it went over to the right too. So let me back this up. It looks just like it, except you took this little snake in the grass, okay, that's got he's hiding under the grass like a little log. Ah. Okay, and you went to the right too. So I'm going to guess that when I get down here, look, it's messing with my x, so it's going to mess with my mind. I bet anything, it's going to go left 3. Okay, so we'll talk about that here in a second. All right, let's do this one real quick. Now, it just kind of makes, well, maybe it doesn't make sense, but we're going to plug in anything we want here as long as it's bigger than 0. Okay, I cannot ever take the log of 0. This really doesn't mess with my x, so I don't care about here. It's what I take the log of. So that's why I always look here and I'm like, ooh, x couldn't have been 2 because I can't take the log of 0. Okay, so back to here. I'm going to plug in anything I want other than 0. One of my favorite things is to plug in a 1 because I know the log of 1. I don't care what the base is, but the log of 1 is 0. 0 minus 2 is negative 2. Okay, so I've got that. Another thing I would love to plug in, since I have a base of 3, is 3. And by the way, if this was base 4, I'd plug in a 4. If this was a base 5, I'd plug in a 5. Okay, kind of like that. And then I would be plugging in, if it was a base 5, I'd be plugging in 5 and 25 and what is that, 125, but who would want to graph that? Okay, so if this is a 3, log base 3 of 3, is 1. 1 minus 2 is negative 1. And I'm going to try another one. If I plug in 9, if this is a 9, log base 3 of 9, that's 2. 2 minus 2 is 0. Use your calculators, okay? Make sure you can figure this out. 1/3 would be another one of my choices. All I'm doing is taking the reciprocal of these. If I'm taking the reciprocal of these, okay, look. If this is 1/3, okay, plug it in your calculator, but that's going to give me negative 1 minus 2 is going to give me a negative 3. Okay, and I'm going to plug in one more. I'll plug in 1/9. If I plug in 1/9, that's going to give me what? Negative 2 minus 2 is a negative 4. Okay, so let's graph these. Let's see what we've got here. I'll graph that over here right below. But I've got 1, negative 2. There we go. I've got 3, 1, 2, 3, negative 1. I've got 9, 0. And by the way, remember my asymptote was still this, because that's what x can't be. So I can see I've got this little slight curve going up. I know it's going to drop down here and hug my asymptote. Okay, so it looks just like that. So remember, my first one was here at 1, 0, and it did this. Look, you can see it. See, it went through 1, 0. This one started right here, so it went down 2. Very interesting. This guy, he went down 2. So it's not going to affect my domain. My domain still couldn't plug in 0. And by the way, look at your graph. You can see the farthest to the left I'm going to 0, and then it goes over to the right to infinity. My range is how high and how low it goes. And by the way, they're always going to be negative infinity to infinity, okay, for your range. And my asymptote is going to be, don't forget the x. All vertical lines are x equals something. This was x equals 0. And I didn't mention that on here because I forgot, but my asymptote here would be x equals 2, okay? Because if x is 2, I would get it undefined. That's not a coincidence right there, okay? The asymptote's what it can't be, all right? It's like that brick wall. All right, so that's these first 3. And I might, let me see how, you know what? I'm going to do these on another video just so it's not quite so long.